Assalamu alaikum. Welcome everyone to another video on ETAP software. Mm, and we were preparing some videos on power system protection using ETAP softwares. And today, this is the fifth video, I think, and we are going to show you that how ETAP can be used to protect the load, okay, using overcurrent relay. So we'll simulate some scenarios where we'll try to show you that different type of loads and how it can be saved by overcurrent relays, and particularly by directional overcurrent relays. So this is the new thing for today. So remember, and the previous videos we showed you that if we have generators, for example, in this power system, we have generator 1 and generator 2. These two generators were protected by this overcurrent relay and this overcurrent relay. So, but for today, our focus is here in the load side. So you can see that we have 4 steps of our experiment. In fact, in the first step, we'll focus on a single load, protection of a single load. This is that load, and you can see this is a lump load, and this lump load is a constant Z type. So that means over here, the total impedance is constant, and we are going to protect it by overcurrent relay protection. So this is the overcurrent relay, and this is the CT who provides the information to the overcurrent relay. Okay, so this will be the first scenario. So let us go to the simulation part. Then we'll come back to the step 2. So in the simulation part, you can see it, the power system is ready here. So we need to modify this part and add a CT over here and an overcurrent relay connected with that. Okay, but before that, we need to see the bus rating. You can see the bus is 11 kV bus. Okay, so that's why the circuit breaker rating should be adjusted accordingly so that it is capable to handle 11 kV. Yeah, so we can see it, see here that it is 15 kV. It is capable to handle 15 kV, this circuit breaker, 15 kV bus. Okay, so yes, over here. So if, for example, your kV rating is selected 4.76, you have to make it 15 or 15.5 so that it is capable to handle 11 kV bus. So same will apply for this circuit breaker also. Go to the rating. You can see this is 4.76 kV. So we need to make sure that this circuit breaker is also rated as at least 15 kV. Yeah, 15 kV. Like, okay. Then this CT, in order to put the correct rating in the CT, we need to see the current rating of the load. Okay, so I entered into the load. What is the current rating? Current rating is 1050 ampere. So I enter into the CT. It should be an IEC CT, and go to the rating. And the current will be 1050 or little higher than that. Let us select 1100. Designation is 5P20, burden is 2.5. Okay. And then you connect one overcurrent relay. Okay, overcurrent relay, and attach it with the CT. Enter into the overcurrent relay. Input should be from the CT20. Output, add here. So as output, we have to add the circuit breaker 18. Okay, circuit breaker 18 should be the output. Okay. And if you go to the overcurrent relay, you select the, first of all, from the library, you bring a particular circuit breaker which matches with your requirement. Let us select the manufacturer Altsom, protection type, not motor, not generator, feeder, and overcurrent relay. P139. This is the only model we have. Click OK. And then you select the definite time relay, and select some, not 0.8, it should be more than 1 pickup. So 1.1, for example. Time dial is as expected. Here pickup maybe 5 times. Okay, decrease the current 0.01. Okay. So I think things are ready over here to run the simulation. So I go to the simulation part and apply a fault in lump 1. Okay, so now I will apply a fault in, so this is the fault insertion. So if I apply a fault in lump 1, let's see what happens. Okay, so we applied a fault in lump 1. We can see that the circuit breaker 19 is tripping first. And then as a backup, this circuit breaker 6 and 8 are tripping. Even though they are not close to the load, but why they are operating? They are operating because we have overcurrent relays to operate this particular two relays, circuit breaker 6 and 8. So you can see that after this, this load, there is no other protection scheme applied in between. So that means this transformer, this transmission line or bus, there is no protection scheme for this. So that means this overcurrent relay, which is relay number 21, it has the coordination with the relay number 5 and 9. So automatically, if this circuit breaker 19 fails to trip, circuit breaker number 6 and 8, they will work as a backup option, okay, which is operated by relay number 5 and 9. So this is actually the case for the first step. So we saw that if there is fault, if there is a fault in this location, if there is a fault in this location, okay, so this circuit breaker will trip at number 1, and this will be tripped as backup. Okay, they will trip as a backup option. So this is actually the first case. Now, second case, or the second step, is to apply the same protection scheme for two loads. Okay, so it will be again a constant Z-type load, but now we will apply it for the another load. By the way, before we proceed further, let us remind you that we are using here lump load. Okay, so if you can see the lump load, there we have two type of loads. One is over here, static load, which is a fixed load. You cannot modify the load type or value. But the lump load, it has the provision to change the load pattern. For example, currently, if I enter into the lump load, you go to the nameplate, you will see that the load type, you see it is written here, load type, this is constant Z 100%. So it means that we are now using the load which is 100% constant impedance type. But if you want to change and make it some percentage to constant kVA, which means it has some motoring action or motoring part, you can do that. For example, if you put it here 50, it means at this situation, this is 50% constant kVA. That means this load has 50% motoring action, and 50% Z. That means it has 50% impedance action. Okay, so for the first case, we use constant Z type. And for the second case also, we will use the same type of load, which is constant Z type. So yeah, we are using this constant Z type. You see this constant Z. However, let us go to the simulation part and copy the CT and paste it in the second line, and the overcurrent relay also copy and paste. Okay, now we need to make sure that this overcurrent relay should trip circuit breaker 19. So that means input is CT22, which is okay. But in output, we need to make sure that we add circuit breaker. Which circuit breaker? Circuit breaker 19. So I have added circuit breaker 19 with it. Okay, yeah. And then go to the overcurrent relay. It is having all the setup. Sorry. Yeah, all the setup we did like before. Yeah, this is fine. Okay. So now let us save the project and run the simulation. So what we have done, we have added the protection scheme for the another load also. Okay. Now, if you apply the same, if you apply a fault in the same location, what will happen now? What is going to happen? So if you apply it here, actually it will follow the same operating scheme of the circuit breaker. Look at it, that circuit breaker 1 is tripping first, then 2, and then 3. Now, you may have a question in your mind that why this relay 23 is not operating, or why this circuit breaker 19 is not tripping. This is because of the type of the load. You see, this is the lump load, but which has 100% Z-type property. It means that, there is no current flowing from the load number 3 or the lump 3. So if the circuit breaker 19 is stripped, it means that, like it clears the fault, isn't it? Because the fault occurs in lump 1. So there is no benefit of tripping circuit breaker 19, because if you trip circuit breaker 19, it will not clear the current flowing, the fault current flowing towards lump 1. I hope it is clear that, let me explain it over here, that, as because this is constant Z type, there is no flow of current back from here. There is no flow of current back from here. This is constant Z type. So that means even if you apply a fault in this location, this will trip first, number 1. If it fails, the current is still going to this location. Okay, so that means in that case, this circuit breaker should trip and this circuit breaker should trip. Okay, so as because this is a constant Z type of load. Okay, it doesn't work as a motor, or it doesn't act like a motor. So that means even if you have 2 loads and the protection scheme for both the loads, the sequence of operation remains same. So 19 will trip first, then circuit breaker 6, and after that circuit breaker 8. Okay, so now let us go to the third scenario. Scenario number 3. Well, still we are applying the overcurrent protection for 2 loads, but look at it. We are making the load type little different. Okay, now we are making 80% PV type. So PV type means this is having some motoring action. Okay, and 20% Z type. So it means that the loads now, the type of the loads now are needed to be changed. Okay, so I go to the edit mode and enter into the lump loads. Okay, enter into the lump loads and just make it 80% PV. Okay, so make 80% PV. Okay, do the same thing for this lump load also. Okay, lump 3. So just enter into it, go to the nameplate, make it 80% PV. Okay, KVA type. Okay, so now if you have, sorry, it should be KVA. By mistake, I have written PV. It should be 80% KVA type. Okay, so KVA type. KVA type. Okay, however, so let us now go back to the simulation and save the project. and apply the fault. So remember before what happened whenever we applied a fault in lump 1, circuit breaker 18 tripped first, but 19 didn't trip because it was constant Z type load. Instead of 19, it went to 6 and 8. Okay. Now let us see if we apply a fault now, what will happen? Okay, so I insert a fault in lump 1. Okay. So whenever I insert a fault in lump 1, is it working? Sorry, it didn't work, I think. Okay, yeah. So whenever I inserted fault in lump 1, circuit breaker 18 is tripping, 19 is tripping at second, and then it is going to circuit breaker 6. Okay, so let's look at it again. 1, then here 2, and here is the 3. Okay, why circuit breaker 19 is tripping now? I hope you know the answer. It is because now this lump 3 is a different type of load. It has some motoring action, and because of the fault, instead of getting the power, it also supplies the power to the fault, or supplies the current to the fault. So that's why it is needed to trip circuit breaker 19. Okay, before it goes to the remote backup, which is circuit breaker 6. So I hope that it is very clear that what is happening here. If like now this is not a constant Z type load, the loads are having some motoring action. That means it has the property that whenever a fault occurs, it gives current. Okay, and it supplies current to the faulty location. So because of that, if a fault occurs at this position, a fault, what happens? This trips, obviously, this is the primary. Okay, this also trips in the second. Okay, that means this is a backup, and the remote backup is this one, number 3. Okay, so this is the operating sequence. Okay, now we will make the scenario a little different. What we are going to do now, just try to understand if circuit breaker 18 trip, for example here, if 18 trips in a fault in lump 1, should it require for circuit breaker 19 to trip? Should the relay 23 operate circuit breaker 19? Answer is no. Why no? Because the fault occurred at this location, lump 1 location. Try to understand this. The fault occurs in this location. So if the fault occurs in this location and this primary relay trips, there is no need that the circuit breaker of another load, it trips as well. So it means that this is actually, you can consider it as a unnecessary tripping. Because if it is clear, the fault is clear. So you don't need to trip this one. So to solve this problem, we will now will now introduce you with directional protection. So in this type of directional protection, actually the circuit breakers, the relays, they can track the flow of power or the flow of current. And based on that, what is the direction of the power flow? Based on that, it can take the correct decision of tripping. Okay. So now how to apply the directional relay? It is very simple. You go to the overcurrent relay, and there is an option when you go to OCR, there is an option directional. You can just select that one, this directional. So whenever you select this directional, you see this is directional 67. So you click on 67, what type of power flow or the current flow it will track. So because the power or the current, it should become as a from the motor or from the load. So we will select the reverse. Okay, so we'll select the reverse and click OK. Same thing we will do over here in overcurrent relay. Go to OCR and select here overcurrent relay. sorry, directional relay. And in 67, you select here reverse. So if in the case of, if you select forward, what will happen here? It will understand that a fault has occurred in the generator end. Okay, that means the flow of the fault current and the flow of the regular current are in the same direction, forward direction. Okay, but actually, as because the fault is occurring in the motor side and we want to track that one, we will select the reverse one. Okay, click OK and OK. Let's save the project and we apply the fault now. So now, if we apply the fault now in the same load, lump 1, let's see what happens. Okay, I bring a fault, insert a fault in lump 1. Okay, now you see circuit breaker 18 should trip first, but yeah, 18 is tripping first, circuit breaker 19 is tripping second. And I think this one, it has some issue over here in overcurrent relay. Let me see. This forward and reverse, it has some impact. No, not that. So just have a look. If you go to this relay, I think I just have to make sure that the direction is correct. This 67, I think it needs to be forward. Let me see. Okay. Apply the fault now for lump 1. 18 is tripping first. Okay, yeah, it is fine. So just have a look. Actually, I forward the this forward and reverse issue. So where you apply the fault, that relay, it should be a reverse, and the another one, it should be forward. Okay, so whenever I'm applying a fault in this lump 1 location, just have a look. It is operating correctly. What is the correct operation? Circuit breaker 18 is tripping first. Okay, and if it trip, so there is no need that circuit breaker 19 trips as well. Okay, so that's why the backup, it goes to circuit breaker 6 and 8. Okay, because this lump 3, even though it is having the motoring action, but as because either you trip circuit breaker 18 or 6 or 8, so it will solve the problem. Okay, so that's why there is no need to trip circuit breaker 19 by relay number 23. So this is actually the last step of the experiment or of the work, where we saw that if we apply a fault over here, and this relays are directional, this is directional and this is directional as well. And if we apply a fault over here, this directional should be selected as reverse, and this should be selected as forward. In that case, this will trip at first. This will not trip. This will trip as second and third, or simultaneously, these 2 and 3. Okay, so this is how the directional protection, it saves the saves this branch. For example, if your circuit breaker 18, this one, trips, in that case, just have a look, the power flows and it supplies lump number 3. So actually it keeps the power system alive by supplying the another load. Okay, so thank you very much for watching the video, and if you have any question, you can write that in the comment section. I hope you have understood and enjoyed the video. Thank you very much.